Question 1. Enzo and Jane are taking a group of children to the beach for a day trip. They go to the shop and they buy some items for the trip. So we have a bucket, a beach ball, a set of spades and a toy duck. Part A, complete Enzo's bill below. So we had 15 buckets. So we're doing 15 times the cost of a bucket. So 15 times 2.35, oh, that's 8, is £35.25. So it's £35.25 for the buckets. We spent £12.30 on spades, so we're going to reverse that and do £12.30 divided by the cost for a set of spades, which is £4.10. So £12.30 divided by £4.10. which is 3. So he bought 3 sets of spades, 17 toy ducks. So we're doing 17 multiplied by the 95p. We're working in pounds, so we're multiplying by 0.95 so that we get our answer in pounds. So that's £16.15. And then our total is just going to be these 3 values added together. So £16.15 plus £12.30 plus 35.25, which is a total of 63.7, which is £63.70. Part B, Enzo is given a 10% discount. How much discount will he get? So he's going to get a 10% discount on this amount here. So to find 10%, we divide by 10. So I'm going to divide that total that I've still got in my calculator by 10 because there are 10 tens in 100. So that's 6.37. So he's going to get a £6.37 discount because they want to know how much discount he gets, not how much it is after the discount. Part C, Jane has £15 to spend. The shop has a special offer on beach balls. Buy 2, get 1 free. What is the maximum number of beach balls Jane can buy? Okay, so let's go back up to the top. Beach balls are £3.20 each. Okay, so I'm going to make a note of that down here. So 1 ball is £3.20. So the offer is buy 2, get 1 free. So you get 3 balls in total, but you only pay for 2 of them. So 3 balls is the same as 2 lots of £3.20. So 3.2 times 2. Remember, do it in your calculator because this is a calculator paper. So it's £6.40 for 3 balls. She's got £15 to spend. So we're going to see how many £6.40s go into £15. So this is 3 balls. So if we do another £6.40 and add those together, that's £12.80. So that's 3 and that's 3. So that's 6 so far. Let's see how much is left from £15 to £12.80. So 15 minus £12.80. So 15 minus my answer is £2.20. Is £2.20 enough to buy 1 ball? No, it's not. We need £3.20. So we've just got those 6 balls in total. So 6 balls are the maximum amount that Jane can buy. Question 2A. Write the number 340,205 in words. Okay, so I just said that number. It's 340,000. So 340,000. So it's 340,205. You don't need the ands in there, but that's how I say it. So that's how I'm going to write it. 340,205. Part B. Shade 1/3 of the following shape. So let's see how many equal parts this shape split up into to start off with. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 parts in total. We want to shade in a third. So I'm going to do 18 divided by 3. Again on my calculator because it's a calculator paper. Okay, so that's 6. So if I multiply that fraction by 6, I get a fraction out of 18, which is the total number of parts I'm dealing with. 3 times 6 is 18. 1 times 6 is 6. So I need to shade in 6 of these shapes. And it doesn't matter which 6 I shade in, as long as I colour in 6 of them. So 1, 2, 3, 4, and we'll do these 2, 5 and 6. So 1, 2, 3, 4, 5, 6 shaded. So that's 1/3 of that shape shaded. Part C, what is the value of the 2 in the number 5.2614? Okay, so the point to notice here is that the 2 is after the decimal point, so it's not an integer, it's not a whole number, so it's definitely not these two because they are integers. 2 over 1, if you're not sure, put that in your calculator, but that gives us 2. That's an integer, so that's not the correct answer. So 2 must have this value or this value. So we're going to look at what place value column it's in. So we've got a decimal point here. The column after the decimal points is the tenths. Because that 2 is in the tenths column, 2 out of 10 is its value. That number on the denominator there, the 10, indicates that we're working with the tenths column. Part D, write these numbers in order of size. Start with the smallest. Okay, so we need to be really careful here because we've got a mix of positive, negative numbers and also decimals, okay? So 6 is the biggest out of all of these numbers, so I'm going to put that in the largest column. So these two decimals are less than 6, but they're positive decimals. So one of these two negative numbers is going to be our smallest number. The more negative a number, the further away from 0 it is. So -5 is the smallest, which means -3 will be there, because then we're just dealing with two positive decimals, one of which will go in each of those squares. So let's compare these decimals. We have 3.6 and we have 3.45. Lining up the place value columns and the decimal point helps here, and then putting a placeholder 0 also helps. So we're going to start by comparing the units or the ones column. Both of them are 3s, so they're the same size in terms of the units. They've got 3 ones in there. So we're going to move to the next column. This is the tenths column. So we've got a 6 and a 4. 6 is bigger than 4. So that tells me that 3.6 is bigger than 3.45. So 3.6 will go here, and then 3.45 will go there. Part E. Here are 4 cards with numbers on them. 4, 3, 7 and 5. Write down the largest 4-digit number that can be made by rearranging the cards. So when we're doing this, we need to think about place value. So if this is our 4-digit number, this will be ones, tens, hundreds, thousands. So for it to be the largest number that we can make, we want the largest card to be in the thousands column because that has the biggest place value. So we're going to put 7 in the thousands. The next largest card would be 5. So that makes 500s. Then 4. And then 3, so 7,543 is the largest 4-digit number. Part 2, write down the smallest even 4-digit number that can be made by rearranging the cards. Okay, so we want the smallest number that can be made, but we want this number to be even. So for the number to be even, it needs to end in an even number. So 0, 2, 4, 6 or 8. 4 is the only even number we have. So we need to make this number ending a 4. But then we want to make sure that the numbers we put in the remaining 3 place value columns give us the smallest possible answer. So rather than putting the largest card in the thousands column, we're going to put the smallest card in the thousands column. So we've used 4 already, so 3 would give us 3,000s rather than 7 or 5,000s. And then we want the next smallest number in the hundreds and then the remaining number in the tens. So 3,574 is the smallest even 4-digit number that can be made. Question 3. The scales below are used to measure the mass of some fruit in grams. Part A. What is the total mass of the fruit on each of the scales? Okay, so we're going to read the scales here for the total mass. So if we look at this scale here, we've got 0, 100, 200 and then 300, but there's a halfway mark. Halfway between 0 and 100 is 50, so that must be 50, 100, 150, 200, 250. And then in this section here that's worth 50, we've got 1, 2, 3, 4, 5. So each of those must be worth 10. So that's 50, 60, 70. So that's 270 grams. This next one then, let's check this scale from 0 to 100 to 200 to 300. The scales work in the same way, so this is good. So that's 50, 100, 150, 200, 250, 300, 350 grams. Part B. Calculate the mass of each pear and the mass of each banana. Assume that each pear has the same mass and each banana has the same mass. So, let's start with the pear to begin with. We can't work with this scale yet because it has pears and bananas, whereas this one just deals with pears, so that's going to give us a good starting point. So 3 pears weigh 270 grams. All right, I'm going to do myself a little proportion table here because I like to organise my working. So this is my number of pears and this is my number of grams. I want to know how much 1 pear weighs, so I need to scale down by dividing by 3, which means I've got to do that with the weight as well. So 270 divided by 3 is 90. So that's 90 grams for 1 pear. Let's pop that on our answer line. So now we need to find the mass of bananas. So this here, we have 1 pear and 2 bananas. So 1p plus 2b, so pears, bananas, is 350 grams. Now I know that 1 pear is 90 grams, so 90 grams plus 2 bananas is equal to 350 grams. And now I can solve this for bananas. So I need to eliminate the 90, so I'm going to subtract 90. So that leaves me with 2b equals, do the same to the other side to balance, 350 subtract 90 is 260. So 2 bananas weigh 260 grams. To find 1 banana, I need to divide by 2. Have to do the same on the other side. So 260 divided by 2 is 130. So 1 banana must weigh 130 grams. Question 4. A. 100 tickets are sold in a raffle. So 100 tickets are sold in a raffle. A ticket is to be selected at random and the person with that ticket wins the prize. Sandra buys 1 of the tickets. Circle the expression that describes the chance that Sandra wins the prize in the raffle. So we're wanting to express the probability that Sandra will win using words. So Sandra buys 1 ticket out of the 100 tickets that are sold. So it's not impossible because she has a ticket and you have to have a ticket to win. It's not certain because she doesn't own all 100 tickets that have been purchased. It's not an even chance because it would be halfway, so she'd have 50 tickets. So it's unlikely because she has less than half of the tickets. So it's unlikely that she will win. Part 2. Henry has 6 pairs of shoes in his cupboard. He picks 1 shoe out at random. Circle the expression that describes the chance that Henry picks out a shoe for his left foot. Okay, so there are 6 pairs of shoes in the cupboard. So 6 pairs of shoes, 6 times 2 means there are 12 shoes in total. He's going to pick 1 shoe out. Okay. Circle the expression that describes the chance that he picks out a shoe for his left foot. Well, there's 12 shoes in total. Half of those will be for the left and half of those will be for the right. So he has an even chance that he picks out a shoe for his left foot. Part B. Zach has a bag containing 12 marbles. 1 marble is green, 3 are red and the rest is blue. Zach chooses 1 marble at random from the bag. On the probability scale shown below, label the points A, B and C, where A is the probability that Zach chooses a red marble, B is the probability that Zach chooses a yellow marble, and C is the probability that Zach chooses a marble that is not green. Okay, so we've got 12 marbles, 1 of them is green, so 1 out of 12 are green, 3 are red, so 3 out of 12 are red, the rest are blue, so we've got 1 out of 12 and 3 out of 12, so that's 4 out of 12 in total. 12 take away 4 is 8, so 8 out of 12 must be blue because that's the remaining marbles. So let's have a look at this first. We're dealing with fractions out of 12. We need to place these probabilities on this probability scale. So let's see what it's split up into. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, that's handy because our fractions are out of 12. So the probability that Zach chooses a red marble is 3 out of 12. So 1, 2, 3. That's A. So we're going to mark with an A there. B. The probability that Zach chooses a yellow marble. We have green, red and blue, but we don't have any yellow marbles. So that's a 0 chance. So we're going to put the B on 0. And then C, the probability that Zach chooses a marble that is not green. So if it's not green, we're having the 3 out of 12 reds and the 8 out of 12 blues. Well, 3 plus 8 is 11. So that's an 11 out of 12 chance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to pop C there. Question 5. 9 shapes are shown below. Complete the following sentences. Shapes something and something only have 2 lines of symmetry. So lines of symmetry are lines we can draw that split the shape exactly in the middle. Okay, so they only have 2 lines of symmetry. So I'm going to say that shape D and shape E, because a rectangle has a line of symmetry here and here, but we don't include the diagonals because not all of the sides of the shape are equal. Shape E, we could split it down the middle here, but we could also split it down the middle here. Any other point and we wouldn't have symmetry on the other side. So D and E have 2 lines of symmetry. So this shape something has rotational symmetry of order 4. So rotational symmetry means that if we turn the shape 360 degrees, it fits into itself exactly 4 times. Well, that's going to be shape B, because B is a square and all 4 sides of the square are the same. So when we turn it, each side will slot onto the other and it'll happen 4 times in a 360 degree turn. Okay, the next one, shapes something and something are congruent. So congruent means exactly the same, okay? They can be rotated, but they have to be exactly the same dimension-wise. So A and H are congruent. They're the same shape. It's just that H has got a different rotation, but the size of the shapes have not changed. They match. And then the last one, shapes something and something are similar but not congruent. So remember, congruent means they don't change size in any way, but they can be rotated. Similar shapes means that they could change size, okay, but they change size within a particular proportion. So we're going to go with C and G. They are both pentagons, but G is bigger than C, so it could be an enlargement of C. Question 6. The table below shows part of a train timetable between Portsmouth Harbour and London Waterloo. So these are the train times, Portsmouth Harbour, London Waterloo. So this is one train. So it leaves at 6:15 and arrives at 7:53. This is another train, the next train, the next train, the next train, the next train, and the next train. That's how timetables work. Part A. Elise catches the 08:45 train from Portsmouth Harbour to London Waterloo. How long should her train journey take? So she catches a 08:45 train. So that's this train here. So this train leaves Portsmouth Harbour at 8:45 but arrives at London Waterloo at 10:29. So we're going from 8:45 to 10:29. So we're going to do this in parts. So to get from 8:45, I can't write, to the next hour, which would be 9 o'clock, that's a 15-minute journey. Okay, so that's 15 minutes. And then to get from 9 o'clock to the next hour, which would be 10 o'clock, is 1 hour. And then we're going from 10 o'clock to 10:29. So from 10 o'clock to 10:29, that's another 29 minutes. So we've got 1 hour and then we've got 15 plus 29 minutes. Which is 44 minutes. So it takes 1 hour, 44 minutes. Part B. Paul lives in Petersfield. So he lives in Petersfield and he works in Guildford. He starts work at 10 a.m. It takes him 15 minutes to walk from the station to work. Paul needs to arrive at work on time. What is the time of the latest train from Petersfield he can take? Okay, so he starts work at 10 o'clock and he lives in Petersfield and he's going to Guildford. So we need to look at trains that arrive to Guildford before 10 o'clock, but allowing him 15 minutes to walk from the train station in Guildford when he arrives to where it is that he works. Okay, so 10 a.m. take away 15 minutes means 9:45 a.m. at the latest he needs to arrive. So we're going to Guildford, so let's have a look. So we've got 9:18, we've got 9:48. 9:48 would be too late because he needs to arrive at the latest at 9:45 because then he's got to walk another 15 minutes to get to work for 10 o'clock. So it won't be this train, this must be the latest train that he catches. Okay, and the time of the latest train from Petersfield, well, where this is our train here, we're looking for Petersfield, so we're going up to this part of the train timetable here. So it's Petersfield, and this is the same train getting him there to Guildford for 9:18. So the time of the latest train he could catch is the 08:47 train. Question 7. Georgia is going on holiday to France. She takes one large suitcase and one piece of hand luggage. The graph below can be used to convert between kilograms and pounds. So we've got pounds and kilograms. Part A. Georgia's suitcase has a mass of 24 kilograms. What is the mass of the suitcase in pounds? So 24 kilograms. So we're going to read across this horizontal axis because that's the kilograms. We're going to 24. So we've got 20 and then 25. Between 20 and 25 is 5, but we have 10 small squares. So 2 small squares is equal to 1. So 24 is 2, 4, 6. 24 is here. Okay, so we're going to mark up from 24 to the graph that's been drawn. And then we're going to also read across. I've done this in pen so you can see it. I would recommend you do it in pencil just in case you make a mistake. So then we're going to read this scale here. So from 50 to 60 is 10. There are 10 little squares, so each square must be worth 1. So that's 51, 52. Then we're halfway between 52 and 53. But it's my line's gone down slightly, so I'm going to go 53. So it's £53. Okay, the next part. Her hand luggage has a mass of 13 pounds. What is the mass of her hand luggage in kilograms? So we're starting on this axis now, 13 pounds. So I'm going to go 10, 11, 12, 13. Read across. And then read down. So we need to remember that this bottom scale, 2 of those small squares was equal to 1. So that gets us to 6. So it would be 6 kilograms. A car hire company in France uses the following formula to calculate costs in euros. This is the formula to calculate costs in euros. So car hire cost equals €11.25 multiplied by the number of days of car hire, add the insurance. So for part 1, Georgia decides to hire a car for 8 days. The insurance will cost her €95. Calculate the cost of Georgia's car hire. So we're substituting in these values into this formula. So car hire equals euros of 11.25 multiplied by the number of days, which is 8. And then we're going to add the cost of insurance, which is €95. But remember, order of operations, we need to do that multiplication first. So even though I'm going to stick this in my calculator, I'm going to pop a bracket around that just to be safe. So 11.25 multiplied by 8, add the £95 for the insurance, is €185. I said £95, I meant €95. Part 2. Mina is also hiring a car from the same company. She has £270 to spend on hire car. Insurance will cost her €126. She wants to hire the car for as many days as possible. For how many whole days can Mina afford to hire the car? We are working in euros here. I don't know why I keep saying pounds. I must be tired. Okay, so we want to see how many days she can hire the car for. So we are going to substitute what we know. So insurance is going to cost her €126. So instead of adding the insurance, we're going to subtract it from how much she has to spend this time. So 270 subtract 126. So she has €144 to spend. It's 11.25 euros per day. So we're going to divide this by 11.25 to see how many whole days. It's still in my calculator. Divide by 11.25. So that's 12.8. Can't see my calculator very well today. So 12.8. We want whole days. So 12 days is what she can afford to hire it for. Question 8. Malik is planning a birthday party for 25 children. He can choose either a swimming party or an adventure centre party. So we've got a swimming party and the costs here, an adventure centre party and the costs here. Malik works out the total cost for each party. He chooses the cheaper of the parties. Which party does Malik choose? So we have to select swimming or adventure centre. We've got to show all of our working out. And they've given us a section for swimming party and adventure centre party. So we've got a section for each set of our working out. We're not going to tick a box randomly. We're going to do some working out. So we have 25 children in total. So let's start with the swimming party. So it's £320 for 20 children and then £7.25 for each additional child. So for 20 children, it's £320. But then we've got 25 children. For those other 5 children, it's going to be £7.25 times 5. So £36.25. So in total, we've got £320 plus £36.25. So that's £356.25. However, there's a special offer. He gets 1/3 off the total cost of the party. So we want 1/3 of £356.25. So we're going to divide it by 3. We divide by the bottom and then multiply by the top. So let's divide by 3. I'm not multiplying by 1 on the top because it would just give me the same answer anyway. So divided by 3 is £118.75. It's 1/3 off. Here, look, that's the important thing. So we need to take that 1/3 away from the total cost. So £356.25 subtract the 1/3. Which is £237.50. So that's the total cost for the swimming party. Let's do the same for the Adventure Centre party and then we can see which would be cheapest. So the Adventure Centre party is £13.60 per child, 15% off the total cost for groups of more than 20. So let's deal with the per child. We have 25 children and it's £13.60 each. So 25 times £13.60 is £340. But then it says we get 15% off the total cost for groups of more than 20. So we have 25, we have more than 20. So we're going to find 15% and take it off that total cost. Okay, so to find 15%, I'm going to find 10% and 5% and then I'm going to add those together. To find 10%, we divide by 10. And to find 5%, I do half of my 10%. So 34 divided by 2. Anything you need to do calculating wise, do it in your calculator, guys, to be safe. We're going to add those together. So 17 plus 34 is 51. So that's our 15%. And we're taking that off the total cost. So 340, take away the 51 is 289. So we need to compare the total cost. This is the total cost for the swimming party. This is the total cost for the Adventure Centre. Okay, the Adventure Centre is clearly more, so the swimming party is cheaper. So we're going to tick that box. Question 9. Rochelle is training for a marathon. For each of the last 5 weeks, she has recorded how many miles she has run. Rochelle runs a whole number of miles each week. Her median is 23 miles. Her mode is 29 miles. And her range is 8 miles. How many miles in total has Rochelle run in the last 5 weeks? You may use the boxes below to help you. And then we're going to put the total number of miles that Rochelle's run at the bottom here. So we're working with averages. So all of them need to be whole numbers, so we're not going to have any decimals. The median is 23 miles, so that's the middle number. So we have 1, 2, 3, 4, 5 weeks, an odd number of weeks, so 23 has got to be in the middle there as the median. Okay, the mode. Okay, the mode is the most common. So we need 29 to appear the most often here, but I'm going to write these in order, so it's going to have to be on this side. So I'm going to put 29 in here twice, because currently it's the mode, because it appears twice, 23 only appears once. So as long as we put 2 different numbers in here, our mode will be 29. The range is 8 miles, so that's the biggest, take away the smallest. Okay, So the biggest, 29, take away the smallest, gives us 8 miles. So we're going to do 29 take away 8, which is 21. So our smallest value must be 21. Now, we don't want to have the same here. We don't want to have 21 or 23 because we need 29 to be the one that appears the most often. So it makes sense here that we've got 21, 23, whole number miles. Let's put 22 in the middle. Okay, so our middle value, our median is 23, our mode, our most common is 29, and our range is 8 miles from 21 to 29, smallest to the biggest. So we want the total number of miles, so we're going to do 21 plus 22 plus 23 plus 29 plus 29. So that's 124 miles in total. Question 10. Two different companies use pie charts to show the proportion of male and female employees. So we've got company A and company B, male employees, female employees, male employees, female employees. Part A, Jamie says company A has more female employees than company B. Give a reason why he may be incorrect. So the reason that he may be incorrect is we actually don't know how many people work for each company. So yes, the males for company A take up 108 degrees of the pie chart, but in company B they take up more of the pie chart. But company A could have a lot more employees than B does. So we can't compare these angles directly. So my explanation of why he may be incorrect is that we don't know how many employees there are in each company. Okay. Part B, calculate the difference between the percentage of male employees in company A and the percentage of male employees in company B. So we want the percentage of male employees in each company, and then we want the difference between them. Now, currently we're working with angles, we're working with degrees, that's not percentages, so we're going to have to convert to percentages. So a full circle is 360 degrees. So in company A, 108 degrees are male employees. So 108 out of the 360 degrees in that full circle are male. So if we put that in our calculator and multiply by 100, it will give us our percentage of males in company A. Remembering to use our fraction button, remembering to arrow off, guys, okay? So that's 30% of employees in company A are male. We're going to do the same for company B. So this time it's 234 degrees out of 360 multiplied by 100. So that's 65%. Remember, we want the difference between the percentages. So we're going to do 65% subtract 35%. Which is a 30% difference. Question 11. A shop sells the same breakfast cereal in two different size boxes. So we have a 500 gram box and a 900 gram box. Which box is better value for money? So we've got to select one of these, but we must show our working out. So we're going to do the working out before we then decide which one is better value. So what we need to do here is find out how much the smaller box costs for an amount that we can compare directly to the bigger box. So they're both 500 and 900 grams, so they're working in the hundreds. So let's put the small box here, and I'm going to use myself a little proportion table. We know how I like those. And then I'm going to put the big box here, and again, its own proportion table. So this is grams, this is how much it costs. So for the smaller box, for 500 grams, it costs £2.21. And then for the bigger box, for 900 grams, it costs 3.78. Now what I want is to find out the cost for an amount that I can compare directly. Now 500 and 900, they're both multiples of 100. So I'm going to work out how much each box costs for 100 grams, and then I can compare them directly because the measurement is the same. So I'm scaling down here from 500 to 100. I would divide by 5. So I'm going to do the same here for the money. So £2.21 divided by 5 is 0.442. We're dealing with money. Normally I'd do 2 decimal places, but I'm going to keep all of those decimal places just in case I need that last one to compare my values. I'm going to do the same on this side. I'm going to make this 100 grams. So we're scaling down. We're going to divide by 9 this time. So I'm going to divide by 9 on the other side. So 0.42. I didn't need that third decimal place, but sometimes another number appears. And if they matched it here, I'd need that third value to compare. Anyway, we can say that for 100 grams, the small box is 44 pence. And for 100 grams, the bigger box is 42 pence. We want better value for money, so we want that cheaper value here. So the bigger box is better value. (12a). Simplify 10a divided by 2. So it's 10a divided by 2. 10 divided by 2 is 5, and then we've got the a left, so our answer is 5a. Part B. Solve 4x subtract 5 equals 2. We know I like to write this out, so I've got a little bit more space. So I'm aiming to solve for the variable, which is x. So I'm aiming to isolate x. So the first thing I'm going to do is I'm going to eliminate this minus 5 here. So to eliminate that minus 5, I need to do the inverse, which is add 5. So when I add 5 to the left-hand side, I get 4x. I have to do the same to the right-hand side to balance the equation. So 2 plus 5 gives me 7. Now I've got 4 times x. I want it to be x equals. I want x on its own. So the inverse of multiplying by 4 is to divide by 4. So 4x divided by 4 gives me x. I need to do the same on the other side. So 7 divided by 4, I can't do in my head. I'm going to write that as a fraction. And I can leave that there because they've not told me what form they want my answer in. So I'm going to leave it like that. Part C, expand. 7 multiplied by g subtract 6. Okay, a couple of different ways you can do this, but you just need to make sure that what's on the outside gets multiplied by everything on the inside. So the first thing I'm going to do is 7 times g, which I write as 7g. And then I'm going to do 7 times negative 6. Remember, you have a calculator. If you're not great with negative numbers, put it in your calculator. So that is negative 42. So I write negative 42 next to my 7g. Part D. Factorise 6x, add 4. So factorising is the opposite of expanding. We're aiming to pull out the highest common factor of all of the terms in this expression, and then what's left goes inside a bracket. So we're bringing a bracket back in. So we've got the terms 6x and positive 4. So we're going to find the highest common factor of 6 and 4. Okay, so factors of 6 are 1 and 6, 2 and 3. Factors of 4 are 1 and 4, and then 2. So the highest common factor is 2. So we're going to put 2 on the outside. 6x divided by 2 is 3x. 4 divided by 2 is plus 2. Notice that the x is inside the brackets because there isn't an x in both terms, so it has to stay where it was. Part E. The shape below is a square. Not drawn to scale, but we can see that this square has a side length of 8x. Find an expression for the perimeter of the square and simplify your answer. So the perimeter is all the way around the outside of the shape. This is a square, so we know that all 4 sides are exactly the same. So we would add these 4 sides together. So I'm simply going to do 8x multiplied by 4. because I have 4 sides that are the same. 8 multiplied by 4 is 32, and then we've got that x, so it's 32x. Part 2. Find an expression for the area of the square and simplify your answer. So the area is the space inside the shape, and for the area of a square we multiply the sides together, so length and width technically for a rectangle, but because they're the same on a square, we're going to do 8x multiplied by 8x. 8 multiplied by 8 is 64. X multiplied by x is x squared. Question 13. Hubert plays a game. He spins these 2 fair spinners. So it's important to know that these spinners are fair. So we've got spinner 1 and spinner 2. Hubert calculates the score. He squares the number on spinner 1 and then multiplies it by the number on spinner 2. Part A, complete the table below to show all the possible scores. Okay, so he squares the number on spinner 1 and then multiplies it by the number on spinner 2. So let's fill in this box here. So the number on spinner 1 is 2 and the number on spinner 2 is 1. So he's going to do 2 squared and then he's going to multiply it by spinner 2. So he's going to multiply that by 1, which gives us 4. Okay, we've dealt with that now. So we're going to do this column here. So spinner 1 is 3. He squares spinner 1 and then he multiplies it by spinner 2. So that's 2. That becomes 18. And then we're going to do this box here. So the value on spinner 1 is 2. The value on spinner 2 is 2. So he squares spinner 1 and multiplies it by spinner 2. So that gives us 8. And then here he squares spinner 1 and multiplies it by spinner 2. We're going to do the same here. So we're back up at the top. So it's 3 and 3. So squares spinner 1, multiplies it by spinner 2. And then we've moved down to the 2 here. So he squares spinner 1, multiplies it by spinner 2. And then down here, he squares spinner 1, multiplies it by spinner 2. And then we're down at this column. So he squares spinner 1, multiplies it by spinner 2. So spinner 2's now got a value of 4. So that's 36. Squares spinner 1, multiplies it by spinner 2. So now we've completed all of those values. Part B. To win the game, Hubert must score more than 9. He plays the game 108 times. How many times would you expect him to win? So if he plays the game 108 times, we need to find the probability that he wins, and then we can use that with the number of times he plays the game to see how many times we'd expect him to win. So he wins if he scores more than 9. So let's have a look in here at the numbers that are more than 9. We're not going to include 9 because it's more than 9. So 18, 27, 36 and 12 and 16. Don't forget 16, you might not have filled that in, but it's definitely a value in that table. So we have 1, 2, 3, 4, 5 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So he's got a 5 out of 12 chance. So if he plays 108 times, we can multiply that probability by the number of times he plays. So 5 out of 12 as a fraction. Arrow out from your fraction, guys, and then multiply by 108. So that tells us that we'd expect him to win 45 times. Question 14. Linda cycles 31.5 kilometres from home to work each day. Part A. One day her journey to work takes her 1 hour and 45 minutes. Calculate her average speed in kilometres per hour. So you might recognise the speed, distance, time triangle. You may work with that. So we've been given our distance, we've been given our time, and we're calculating speed. So speed is the distance divided by the time. So distance divided by time. So we know our distance is 31.5 kilometres. We've got our time as 1 hour and 45 minutes. Now, when we're calculating with time, we need it as a decimal, guys. So we're going to have to convert 1 hour 45 minutes into a decimal. So we have 1 hour, and that 45 minutes is 45 out of 60 minutes, because it's 60 minutes in an hour. So that's 3/4, so that's 0.75. So we have 1 hour plus 0.75. So we have 1.75 hours. It's important that we don't write 1.45, guys. That's what a lot of people do. We've got to convert it to a decimal. And then we're going to carry out this calculation. So 31.5 divided by 1.75 is equal to 18. Okay, so she travels 18 kilometers per hour. Part B. Linda cycles home following the same route. She leaves work at 4 p.m. Her average speed on this journey is 15 kilometers per hour. What time does Lydia arrive home? You must show all your working out. Okay, so we have speed. We have our distance. It's the same journey. Okay, so we're still working with this triangle, but we're working out time because we want to know what time she arrives home. So we're going to have to work with the fact that she left at 4, but we don't know how long it took her. So we have speed, we have distance, we're working with time. So time is equal to distance divided by speed. Okay, so we know our distance is 31.5. We know our speed is 15. So 31.5 divided by 15 is 2.1 hours. Now we don't know what 2.1 hours is in terms of hours and minutes. It's definitely 2 hours because we've got that 2 in the whole number part, but what's 0.1? So 0.1 times 60 tells us that that's 6 minutes. So it takes 2 hours and 6 minutes to get home. She leaves at 4 p.m. So 4 p.m. add 2 hours would take us to 6 p.m. and then add those 6 minutes would take us to 6:06 p.m. You can write it like that with p.m. or you can write it in 24-hour clock. It doesn't matter which. Question 15. Find the value of x and the value of y. So we're working with parallel lines here. Remember, these arrows indicate that these two lines are parallel, and both of these parallel lines have these transversal lines that cut through them. So we're working with the angle facts for angles in parallel lines. So let's look at x first. So here we have 3x. We're trying to find the value of 1x. So the first thing we need to identify is if we have any corresponding alternate co-interior angles that we can work with. So these are the two parallel lines, and what I'm just going to indicate here for you is this F shape, okay? So these are the two parallel lines. This tells us on this F shape that these two angles here are corresponding. If they're corresponding angles, okay, so I'm going to write that there. If they're corresponding angles, they are equal to each other, okay? And they're corresponding because they're on the same side of each parallel line, on the same side of this line that cuts the transversal, and then on the same side of each parallel line. So 3x must be equal to 126. So to solve for x, 3 multiplied by x, the opposite of multiplying by x is to divide, multiplying by 3 is to divide by 3. 3x divided by 3 is x. Do the same on the other side to balance it. 126 divided by 3 is 42. So straight away we can say that x is 42 degrees. Dealing with y now. So looking at this side here, we have 2y here. Now what we ideally would want is an angle here, they are corresponding, or an angle here, they are alternate. So we can find one of those two angles, and I'm going to find this angle here because this is a straight line. So 180 subtract 152, angles on a straight line, add to 180 is 28. So this angle here is 28 degrees. Now we're going to draw another thing on here. So this is our parallel line. This is our parallel line, and then down here, so that Z shape that identifies alternate angles. So angles that are on alternate sides of the transversal that cuts these two parallel lines. So these angles are equal. So these are alternate angles and they are equal. Sometimes exams ask you to write reasons. They haven't asked for reasons here. I'm just writing this here for your notes. So 2y must equal 28. So 2y equals 28. So same again, we're going to solve for y. 2y is 2 times y. I want it to be y equals. I want to isolate y. The opposite of multiplying by 2 is dividing by 2. So 2y divided by 2 is y. Do the same on the other side to balance the equation. 28 divided by 2 is 14. So y is 14 degrees. Question 16. Calculate the value of this sum and give your answer correct to 1 decimal place. So we're going to enter this into our calculator, guys. That's on a calculator paper. But I need to enter in exactly as it is there. So the first button I'm going to press is the fraction button because everything's in a fraction. On the top of my fraction, I've then got this square root. And inside the square root, I've got 1,456. Now I'm going to move to the bottom of the fraction, so I'm going to arrow down. So I've got 1.3 cubed, so 1.3 cubed. And then we are subtracting 0.7, so subtract 0.7. Double check that it matches exactly as it is on the paper there. No need to arrow off this time because we've got nothing else to enter. We're just going to press equals. So to start with, I'm going to write all of this down on my piece of paper. It's a 2-mark question. So this, enter correctly into my calculator, is going to get me 1 mark. And then the last step is to round to 1 decimal place. So 1 decimal place is 1 place value column after the decimal point. So this is what we're interested in, but we have to check the next number. If it's 5 or above, it makes this place value column go up by 1. So 25.489, etc. becomes 25.5 to 1 decimal place. Question 17. Tobias has a tank in the shape of a cuboid. It has length 40 centimetres, width 25 centimetres and depth 32 centimetres. He uses a jug with a capacity of 2 litres to fill the tank. The tank and the jug are shown below. So diagrams aren't drawn to scale, so we can't measure anything directly from them. We've got our dimensions of our tank, which is the shape of a cuboid, and then our jug that has a capacity of 2 litres. Tobias fills the jug to the top with water and pours it into the tank. He repeats this process until the tank is full. How many times does Tobias fill the jug? Okay, so we first of all need to find the volume of the tank. So we know how much water is going inside there. So to find the volume, we'll multiply 32 by 40 by 25. 32 by 40 by 25. Okay, so that's 32,000 centimetres cubed. This jug capacity is 2 litres, so 2 litres is equal to 2,000 millilitres, and 1 centimetre cubed is equal to 1 millilitre. So we can work with centimetres cubed and millilitres now because they're comparable. So that's important to note. So we want to see how many jugs will be needed to fill this tank. So we're going to divide the volume of the tank by the volume of the jug. So divided by 2,000. So that's 16. So there are going to be 16 jugs filled. So Tobias fills the jug 16 times. Question 18. Nathan and Lucy make and sell wooden items for gardens. Part A. Nathan makes and sells benches, tables and tool sheds. Last year the profit he made from selling these items was in the following ratio. So benches to tables to tool sheds, 2 to 3 to 7 for the profit. Part 1. What fraction of his profit did Nathan make from selling benches and tables? So we're going to write each part of this ratio as a fraction to start off with. So this total number of parts in the ratio is 2 plus 3 plus 7, which is 12. We're interested in benches and tables. Okay, so benches was 2 out of 12 and tables was 3 out of 12. We want the fraction of his profit he made from selling benches and tables. So we've got 2 out of 12 plus 3 out of 12. If you're not comfortable with fractions, stick that in your calculator, making sure to arrow off your fraction. So that's 5 out of 12. But you could also recognise that the denominators are the same, so we can simply add the numerators. So the fraction of his profit that he made from selling benches and tables is 5/12. His total profit was £18,072. How much profit did Nathan make from the sale of the tool sheds? Okay, so we have benches, tables and tool sheds, 2 to 3 to 7. The total profit for all of these was 18,072. So I'm going to share 18,072 into this ratio. Now I already know the total number of parts is 12. So 18,072 divided by 12 tells me what one part is worth. So one part is worth 1,506. I'm interested in tool sheds, which is 7 parts. So 7 times 1,506 is £10,542 profit from the tool sheds. Part B. Lucy makes and sells planters. Each planter costs Lucy £32 to make, and each one she sells makes a profit of £80. What is Lucy's profit from the sale of one planter as a percentage of the cost to make the planter? So we're going to start by writing the profit as a fraction of the cost to make it. So she makes a profit of £80, but it only costs £32 to make that planter. So she's got £80 over £32. And if we multiply that by 100, 80 over 32 multiplied by 100, there's a 250% profit. Don't be thrown by the answer. We can make a 250% profit because she's made a lot more back than what she's sold. Question 19. The table gives a summary of the masses, grams of 30 buzzards. So here's our table. Part A. Moen uses the midpoint of each group to calculate an estimate of the mean mass of these buzzards. He does this correctly. Calculate Moen's answer. So we're using the midpoint. So the midpoint is halfway between these two values in the range. If you can't spot it, add them together. So 600 plus 700. And then divide by 2. So that midpoint is 650, 750, 850, and then 950. So to estimate the mean, we're doing 650 multiplied by 8, 750 multiplied by 7, 850 multiplied by 4, and 950 multiplied by that frequency of 11. Okay, we're going to add these up, so we're going to total these values. Okay, so that's the total, or the estimated total. We've got 30 buzzards in total, so to find the mean, we're going to divide by 30. So the mean mass of these buzzards is 810 grams. Part B. Dita decides to estimate the mean mass of these buzzards. She uses the values 600, 700, 800 and 900 rather than the midpoints. Explain why her method is unlikely to give a good estimate of the mean mass. Okay, so she's using the lowest point, so the lowest value that these data points could be. So she's using the lowest values, so her mean's likely to be too small. So it's going to be too small. Question 20. Debbie collects data about a group of 20 people. Her data is the total number of years for which they've owned a pet, so that's the horizontal axis, and the number of visits they've made to their doctor in the last year, so that's the vertical axis. The scatter graph shows her results and her attempt to draw a line of best fit for the data. So that straight line is her line of best fit. Part A, make a criticism of Debbie's line of best fit. So a line of best fit gives us an average that we can predict from, okay? So Debbie's line of best fit does follow the trend of the data. However, there are no points above the line. So it's not really giving us an average of those data points. We want it to be more in the middle. So we're going to say there are no points above the line. So we can't really use it to predict because it's following the trend of the data, but it's not giving us an average roughly in the middle. Part B. Debbie says, because there is a negative correlation, owning a pet for longer causes people to need to visit the doctor less often. Is Debbie correct? Yes or no? Explain how you decide. So we've got an explain how we decide. So we're going to need to think about this before we tick yes or no. Okay? So yes, there is a negative correlation. According to this graph, there's a negative correlation, but correlation doesn't imply causation. Okay? So there could be another reason so owning a dog would mean you took more exercise, for example. But we can't say that. So we're going to say that there's no relationship between these two things. There's no relationship between owning a pet and visiting the doctor. Okay? It's just coincidence. Or owning a pet has nothing to do with going to the doctors. So correlation does not imply causation. There is no relationship between them. It is just coincidence. Question 21. Janet invests £5,000 in a savings account for 9 years. She makes no further payments into or out of her account in this time. Okay, so that £5,000 is all that goes in there. For the first 5 years, her investment earns 2% compound interest per year. After this, the interest rate decreases to 1.3% compound interest per year. How much is Janet's investment worth at the end of the 9 years? So we've got an investment of £5,000 and then we're going to multiply it. Now I want decimal multipliers for these percentage increases. Okay, so for the first 5 years, so the first 5, it's 2% compound interest. So she gets 100% plus 2%, which is 102%. If I divide that by 100, 102 divided by 100, that's a decimal multiplier of 1.02. So it's 1.02 for the first 5 years. So I'm going to put that to the power of 5. Okay, we're doing 9 years in total. So what about those other 4 years? Well, after this, for the next 4 years, we have an interest rate of 1.3%. So we've got 100% plus 1.3%, which is 101.3%. I want a decimal multiplier, so I'm going to divide that by 100. 101.3 divided by 100. So that's 1.013 as a decimal multiplier. So I'm going to multiply by 1.013 0.013, but that's for the next 4 years, so that's to the power of 4. And I'm going to stick this in my calculator. So 5,000 multiplied by 1.02 to the power of 5. Arrow out of your power, guys, so that you can then multiply by 1.013 to the power of 4. Just check I've put everything in right. We know that I make mistakes when I enter it in my calculator. Press equals, so that's £5,813. I'm going to write the whole thing out to start off with, but we're working with money. So after those 9 years, the investment is worth £5,813 and 11 pence. Just check what they're asking for. How much is the investment worth at the end of the 9 years? There we go, £5,813 and 11 pence. Question 22. Circle the correct conversion of 7 metres cubed to centimetres cubed. So if I was going from metres cubed, ignore that. If I'm going from metres to centimetres, I would multiply by 100. But I'm going from metres cubed to centimetres cubed, so I need to multiply by 100 cubed, okay? So to convert 7 metres cubed to centimetres cubed, we're doing 7 times 100 cubed. So do that on your calculator. 7 times 100 cubed, which is 2, 3, 4, 5, 6. So that's 7 million. So make sure we're doing the correct one. Part B, the diagram shows a shape made from a trapezium and a circle. So we've got a trapezium and then we've got a circle. The parallel sides of the trapezium are tangents to the circle. So we can see here that they don't cut through the circle, they just touch it at a point. The diameter of the circle is 30 centimetres and that's labelled on there for us as well. The ratio of the white area to the shaded area is as follows. So white area to the shaded area is 1 to k. Find the value of k. Show all your working and give your answer to one significant figure. Okay, so first of all, we are working with area. So I'm going to start by finding the area of the trapezium, the area of the circle, because that's going to help me and that's going to get me some marks. Okay, to find the area of the trapezium, I add the two parallel sides together. So I'm just going to put trapezium here so we know what we're working with. So add these two parallel sides together. So 62 plus 79. Then I multiply them by the height, so the distance between them. So 141, don't know why I'm writing a divide there, that's my brain. 141 multiplied by 30. And then I divide by 2. So this is the area of the trapezium. Okay, area of the trapezium. I'm now going to do the circle. So the area of a circle is pi times the radius squared. So we're doing pi times, the diameter is 30. So the radius is half of that, which is 15. So I'm doing pi times 15 squared. So pi times 15 squared is 225 pi. And I'm going to leave that as 225 pi to start with so that I'm not dealing with what is quite a messy decimal. So I have the area of the trapezium and I have the area of the circle, okay? Now we're going to deal with this ratio. So the ratio is the white area, the area of the circle, to the shaded area. I don't know the shaded area yet, but I can find it. The shaded area is the area of the trapezium, subtract the area of the circle. So the shaded area is 2,115, subtract 225 pi. So that's 1408.141653. So that's the shaded area, okay? So the area of the circle, so the white area of the circle is 225 pi to the shaded area, which is 1408.141653. Okay, we need the value of k. So this is worth 1. So what we would do is divide by 225 pi. So I'm going to do the same on the other side. So this answer in my calculator divided by okay, is 1.992119293. Okay, so we want it to one significant figure. So this is K here, remember, that's the part of the ratio to one significant figure. So the first significant figure is the 1, but the value after it can change it, okay? That 9 is 5 or above, so that is going to go up by 1. So our ratio is 1 to 2, so K equals 2. And that's our final answer. Question 23a. Solve 5x add 4 equals 2x add 6. So we know that I like space to do this, so I'm going to copy it here. So we are solving for the unknown variable, which is x. X appears on both sides. So the first thing I need to do is eliminate the smallest lot of x. So we've got 5x and 2x, both of them are positive. 2x is the smallest term that has our variable in it, so I'm going to eliminate that. So it's a positive 2x. I know it's positive because there's no negative sign. So to eliminate it, I need to subtract 2x. When I subtract 2x from the left-hand side, 5x subtract 2x is 3x. The 4 stays there. I've done nothing with that. I'm only dealing with the x terms. When I subtract 2x from the right-hand side to balance the equation, that eliminates the 2x and just leaves me with 6. Now I've got a 2-step equation here, guys. So the next thing I'm going to do, I'm aiming to isolate the x term. So I'm going to eliminate the positive 4. The opposite of adding 4 would be to subtract 4. So the left-hand side subtract 4 leaves me with 3x. We eliminate that plus 4. But I need to do the same to the right-hand side to balance the equation. 6 subtract 4 is 2. Remember, you can do all of this in your calculator if you need to. Now we have a 1-step equation. This is 3 multiplied by x. The opposite of multiplying by 3 would be to divide by 3. So 3x divided by 3 gives us x on its own, isolated. We've got to do the same to the right-hand side. So 2 divided by 3. I'm just going to write as a fraction 2 over 3. I don't need to write it in any other way. It's not asked for it as a decimal or anything. So that's my final answer. Part B, solve. 4x subtract 3 is greater than 17. So 4x subtract 3 is greater than 17. I'm going to solve this like a normal equation, but instead of writing an equal sign, I need to write that symbol there. So we're aiming to solve for x, okay? So we're isolating the x term. So the first thing I'm going to do is eliminate that negative 3. The opposite of a minus 3 is to add 3. So when I add 3 to the left-hand side, I have 4x. The negative 3 is eliminated, so then we are greater than, but I need to add 3 to the right-hand side, so 17 plus 3 is 20. Remembering to keep that symbol exactly as it is, guys. Now we have a 1-step equation. This is 4 times x is greater than 20. The inverse of multiplying by 4 is to divide by 4. So if I divide by 4, 4x divided by 4 is x. So I've isolated x on its own. I've kept my symbol the same, but I need to divide by 4 on the right-hand side to balance the equation. 20 divided by 4 is 5. X is greater than 5 is our whole answer, guys. That needs to be written. If there's an answer line, it's got to be written x is greater than 5. All 3 parts need to be there. Part C, solve the following simultaneous equations. Use an algebraic, not graphical method. You must show all your working out. Okay, so when I'm solving simultaneous equations, I'm going to compare the variables and see if they have a matching coefficient. So I have 5x and 1x. Their coefficients doesn't match. That's 5, that's 1. I have minus 2 and minus 1. Their coefficients don't match. This is a minus 2, this is a minus 1. So I need to make a coefficient match so that I can eliminate one of these variables to start with. So I'm going to multiply this equation by 2. So when I multiply this equation by 2, everything gets multiplied by 2. So x times 2 is 2x. Minus y times 2 is minus 2y. And 5 times 2 is 10. And then I'm just going to write this equation above. I don't need to change this equation because if you look now, guys, the coefficients of my y terms match. It doesn't matter what the signs are, but both y terms have a 2 as a coefficient. So this is good. Now we're going to eliminate the y terms, the y variable, because that's the one that has the same coefficient. So I'm going to do a sum here, but I need to look at the signs to see what sum I do. Okay, if the signs are the same, I need to subtract my equations to eliminate the variable. Okay, so I'm subtracting. 5x subtract 2x is 3x. Negative 2y subtract negative 2y becomes negative 2y plus negative 2y. So they are eliminated. And then 16 subtract 10 is 6. Now we've got a one-step equation. 3 multiplied by x is 6. The inverse of multiplying by 3 is to divide by 3. 3x divided by 3 is x. Do the same on the other side to balance the equation. 6 divided by 3 is 2. So x equals 2 is one of our solutions. I'm making that clear because I don't have a line for x and y here. So I'm making it nice and clear there. Now that I've found my x value, I can use that and substitute it into one of these equations to find y. I'm going to go with this equation here. So x minus y equals 5. I know x is 2. So 2 minus y equals 5. I substituted that 2 in for the x. Okay. Now what I'm going to do is I'm going to isolate the y term. So I'm going to eliminate this 2 to start off with. It's a positive 2. I know it's a positive 2 because there's no negative sign in front of it. So the first thing I'm going to do is subtract 2. When I subtract 2 from this side, it eliminates the 2, leaves me with minus y. I need to do the same on the other side. Don't forget, 5 subtract 2 is 3. Now what you need to be careful of here, guys, is that negative sign. We don't want negative y. We want positive y. Okay? So this is negative, and that's technically a 1. So we've got negative 1y. So that's negative 1 multiplied by y. So what we need to do is divide by negative 1 to do the inverse. So negative 1y divided by negative 1 is y. But we need to do the same on the right-hand side. So 3 divided by negative 1. If you're not sure, do this on your calculator, guys, because it's easy to make a mistake with negative. So 3 divided by negative 1 is negative 3. So y is negative 3. I'm going to highlight that because we don't have a separate answer line for those. Question 24. So we have a diagram here, not drawn to scale, so we can't measure anything directly from it. So the diagram shows a rhombus, A, B, C, D. So A, B, C, D, this is a rhombus. Now a rhombus tells us that all of these sides are exactly the same size. Okay, so be aware of that just in case it's helpful. AC and BD intersect at E. So the line AC and the line BD intersect at point E. The length of AC is 12 centimetres, so the line A to C is 12 centimetres long. BCE, the angle is 35 degrees. So BCE, this angle is 35 degrees. Find the perimeter of ABCD. So we want to find the distance all the way around the outside of this rhombus. Now, the helpful thing here is it's a rhombus, so all 4 sides are the same. So what I'm going to do is I'm simply going to work with one of these triangles that's been formed because all 4 sides are the same. So these triangles must be congruent triangles. So I'm going to work with this triangle here because this is the one they've labelled my angle in. Now, where AC and BD intersect forms a right angle. So this is a right angle triangle. Okay, I know this other angle, but I also know what the base of the triangle is because E is the midpoint, A to E, E to C, all the way is 12. So that must be 6 centimetres to start off with. So what I'm going to do to make things a little bit clearer is I'm just going to sketch this right angle triangle that I'm using here. Okay. So we have a right angle, we have 35 degrees, and we know that this is 6 centimetres. So I've just pulled that triangle off. Now we're going to find the hypotenuse, the longest side, because that's one of the sides of the rhombus, and I know that all 4 sides are the same, and I need to add all 4 sides for the perimeter. So we're going to find this side. So we have got a right angle triangle, a length and another angle. So we're going to be working with trigonometry, guys, okay? So let's start by labelling the triangle. So opposite the right angle is always the hypotenuse. Opposite the other angle is always the opposite, which means this is the adjacent side. Now have a look at which sides we have information for. So we know the adjacent side is 6 centimetres. We are looking for the hypotenuse, that's x. We're not interested in the opposite side at all. We're interested in the adjacent and the hypotenuse. So you may use SOHCAHTOA. It's the cosine ratio that deals with the adjacent and the hypotenuse, guys, okay? So we're working with cosine. So we're going to say that the cosine of our angle 35 is equal to our adjacent over our hypotenuse. So all I'm going to do at this point is substitute in what I know. My adjacent is 6 centimetres. My hypotenuse is the value that I'm looking for. Okay, if you're comfortable with algebra, you can rearrange this equation to solve for x. If you're not comfortable with algebra, we're going to use this formula triangle to tell us what to do next. So we're looking for the hypotenuse. If I cover up the hypotenuse, I'm doing the adjacent divided by cosine. So the adjacent is 6, so x is equal to 6 divided by cosine of the angle. Okay, these things here are what get you marks. So keep these in here to show that you understand how trigonometry works. But if you struggle with algebraic rearranging, use your formula triangle to help you. So I'm going to pop this into my calculator. So I'm going to put it in as a fraction, 6 over cos, and then it's 35, close my bracket. So x is 7.324647533. Okay, so that's one side. That's this side of my rhombus. I want the perimeter, so I want 4 lots of that. So I'm going to do the perimeter equals 4 times 7.324647533. I left that in my calculator because I didn't want to type that all back in again. So I'm going to simply press times by 4. So that gives me 29.29859013. I've written it all out here. There's not a lot of space on there to write it. They don't tell me how to round it. So I'm just going to do it's 29.3 to 1 decimal place.